Get out of there. Alright, so this is the Unit 2B sample test. Unit 2B, that's what I'm currently calling this unit in the 2023-2024 school year. And basically it's the unit on factoring. So this is the test on factoring polynomials, only with the GCF method and with the unfoil method, or factoring into two binomials. So here we go, 12 questions. This is just like what the test is going to look like. So here we go, and there's going to be these green comments for I think every problem, and you can write those down, you can not write them down, but they are kind of important, and it's kind of what, I don't know, what you should basically be going through mentally with your decision making, or like kind of like a strategy. Anyway, so the first thing you should always check for is a GCF, a greatest common factor. Always try that method first. So problem number 1, is there a greatest common factor of 3x and 18? Yes. And if there is, you're going to factor the GCF out in front. So what is the greatest common factor? 3. So we're going to divide 3 out in front from both the terms. And whatever is the remaining factor, goes in the bubble. So 3 times x is 3x, and 3 times 6 is 18. Remember, factoring out a GCF is like the distributive property, the basic distributive property, in reverse. It's like you're undistributing a 3. And that's all there is to it. That's number 1. That's it. Okay? Now, something that I'm going to be following up on throughout this sample test video is that whenever you factor out a GCF, which here we factored out a 3, you always need to check the other factor to see if we can factor it again by unfoil. So technically you should be checking to see if x plus 6 can unfoil, and of course it cannot, not even close. So this one's done. Number 2, again, it's going to be like literally every problem. Is there a GCF? Can you divide the same factor out from all 3 terms? All three terms. And the answer is no. So unfoil? Well, yeah, it's the only hope. And because the first term is just x squared, it's probably going to be, well, it needs to be just a basic unfoil problem if it's going to unfoil, which of course it will. There's not going to be any problems on this sample test that literally don't factor at all. It's either going to be GCF or unfoil, or a combination of both. So when you see that there's just an x squared leading off your polynomial and you're unfoiling, that means it's going to be just basic, easy method unfoil, where you set up your bubbles, because this is unfoil. Unfoil means you're setting up a binomial times another binomial, and considering that it's just x squared up here, it's going to be x and x to start the bubbles, and then here we go. The way you complete or finish each bubble, or both bubbles, is with the 2 numbers that multiply to make this last number, but they also add up to the middle number, the middle coefficient. Okay, and again, this might be, it's worth taking the time here in this video to kind of to address this. For some of you, it's going to be a much longer process than others. There's certain students out there that can just look at most of these, trinomials and come up with the 2 numbers that do the job in a second or a few seconds or less. It might take other people way more time. They might need to grab a calculator or write down all the different possibilities of numbers that multiply, all the different combinations of numbers that multiply to make negative 24. If I was going to list these on paper or in my head out loud, I would go like, well, we got negative 1 and positive 24. We got positive 1 and negative 24. There's negative 2 and positive 12. There's positive 2 and negative 12. There's negative 3 and positive 8. There's positive 3 and negative 8. There's negative 4 and positive 6. And there's positive 4 and negative 6. Hopefully I didn't repeat anything there with negatives and positives. Hopefully I mixed and matched those correctly out loud. But yeah, some people might have to like literally use a calculator to come up with some of those pairs, and that's fine. Don't get frustrated. Some of you might have to like literally write those down. The bottom line is you're looking for the two numbers with the correct negative positive signs that multiply to make negative 24, but they also add up to negative 5. So it looks like the two numbers, if you haven't thought of them already, is going to be a negative 8 and a positive 3. And that's it. That's the answer. You know, and if you ever wanted to check, you could just kind of refoil these two binomials together and just double check that it's actually the same as x squared minus 5x minus 24. Number 3, is there a greatest common factor? You always check for that first. And it turns out that yes. Yes, there is. And the factor, the largest factor that can be divided out from both terms is really just 2. Because both of these terms don't have an x. This one has an x squared or a couple factors of x, but this one doesn't have any factors of x. So there's no x's in common. There's no x factors in common. So the only GCF is 2. And when you divide out a 2 from this term, what's left over is x squared. And when you divide a 2 out from the 50, what's left is 25. Okay? Now again, I said I was going to follow up on this throughout the video. After a GCF, you have to check to see if this, bubble factor factors again, and it would have to be by unfoil. So does this unfoil? And this is where I almost wish I had other green comments to go along here. Just literally saying pretty much what I just said, how after you factor out a GCF, remember to check for this bubble to factor again. That'd be a green comment that you could add if you want. But x squared minus 25, guess what? That totally does factor, So the 2 comes down. We already have a factor of 2, but this bubble is going to break up into 2 other bubbles by unfoil. Now remember, when you only have like a binomial that you're trying to unfoil, it needs to be what we're calling in class a special case, a difference of 2 perfect squares. And remember, if it's the difference of 2 perfect squares, like x squared is a perfect square, and what multiplies together by itself is x times itself. So that's what goes in to start the bubbles, the binomials. And then 25 is a perfect square, and the square root is 5. So that's what you always do. When it's the difference of 2 perfect squares, there's going to be basically the same 2 binomials, except one's got a plus and one's got a minus. And look, by the way, not to kind of keep throwing things at you here, but another way you could have approached this, I guess you didn't have to notice that this is the difference of 2 perfect squares. And so the square root of x squared starts the bubbles, and the square root of 25 completes each bubble. You could have done it that like I did. But you also instead could have said, well, the middle term here is technically 0x. You could have squeezed in a 0x in the middle. Like this could have ended up saying x squared plus 0x minus 25. And then you could play the same game. you did here, where it's like what two numbers multiply to make negative 25, but they also add up to 0. And that could have also gotten you these two binomial factors from unfoil, okay? Moving on to number 4. Don't want this video to take forever. Sandlot reference. So number 4. GCF, think about it for a second, or 2, or 3. Pause the video if you have to. I mean, you do have that power. You also have the power to speed me up, like the playback speed. You could like multiply my talking speed by 2, right, on YouTube. But is there a GCF? Could you factor out? Could you divide the same thing away from all 3 terms? No. There is no GCF, other than positive 1, which doesn't count usually. So unfoil, like we're going to see if, can we unfoil? Well, yeah, like I said, we're going to have to factor some way on all these problems. But look, when you see that the first term is not just x squared, this is 4x squared, the Phoenix method is what you probably want to do. It's definitely what I've been recommending big time. It's the only method I probably showed you to unfoil when it gets a little bit tougher. So here we go. The steps of the Phoenix method. First step is to get rid of the Phoenix by multiplying this 4 to the other end, the negative 5. So then it becomes minus 20 at the other end. So x squared minus 8x minus 20. The second step of the Phoenix method is now you can do basic unfoil. Now that there's no 4 out here anymore and it's just x squared and the bubbles can just start off with x and x, that makes it basic unfoil where, hey, what two numbers multiply to make negative 20, but they also add up to negative 8. Look, pause the video if you need to, if you want to think about it, come up with the numbers by yourself. Last chance to pause the video. Because the two numbers are, if you go through all the possibilities, eventually you're going to realize that it's negative 10 and positive 2 that do the job. Okay? The next step of the Phoenix method, the reason it's called the Phoenix method, is for the Phoenix to rise from the ashes. Might be a better color of like orange for that, So there we go. The Phoenix rises from the ashes by dividing it into these two numbers. And then after that, you take these two fractions you just made. All of a sudden, you have these two fractions. And guess what? You're going to reduce the fractions if you can. Any fraction you can reduce, reduce it. 10 over 4 becomes 5 over 2. If you have trouble reducing fractions, the calculators we currently use in class can reduce fractions for you, as long as you're in the right mode and push the right buttons. But 10 over 4 reduces to 5 over 2, 2 over 4 reduces to 1 over 2, and then the last step of the Phoenix method is any denominator that's left over is going to get bumped up in front of the x in that bubble. So the final answer, the final factors are 2x minus 5 and 2x plus 1. And that's the Phoenix method, and this is when you use it. Number 5, is there a GCF? Because you always check for that. Is there a GCF? No. And then so unfoil? Well, yeah, of course. And by what method? Well, since the first term is just x squared, we're talking basic unfoil. So again, pause the video in the next few seconds if you want to, because you're going to be needing to come up with the two numbers that multiply to make 16, positive 16, but they also add up to positive 17. I know it's going to be two positives. Remember, pause the video, last chance, if you want to come up with it yourself. All right, the two numbers that do the job are positive 16 and positive 1. By the way, it doesn't matter which bubble you put which number in. It could have been the x plus 1 first, and then the x plus 16, whatever. But this one's done. That's it. Number 6, almost halfway there. Living on a prayer. Number 6, is there a GCF? Heck no. Like, no, of course not. Look at this. What could you divide from both n squared and 16, or technically negative 16? Nothing. Nothing that counts. So no. So yeah, this is going to unfoil. How would it unfoil? How would this unfoil? Notice how there's literally only two terms. It doesn't look like your typical, well, how about that? That's what it says. It doesn't look like your typical unfoil problem, but it will as long as, are you kidding me? I have to like correct this in real time here. That's embarrassing. But it will unfoil as long as it's the difference of two perfect squares, which it is. N squared is a perfect square, and 16 is a perfect square, and it is a difference of two perfect squares. If that minus was a plus, guess what? It wouldn't factor at all. So then it wouldn't be on the test. But I'm just saying, this is the difference of two perfect squares. And remember, you could have also approached it by thinking, well, if there could be a 0n in the middle, and then, negative 4 times positive 4 is negative 16, and negative 4 plus positive 4 is 0, and anyway. Number 7, is there a greatest common factor? Because you always check for that first. Always. You do not automatically start the Phoenix method if there's a GCF. So is there a GCF? Yes. So we factor it out in front. GCF turns out to be 2. You can divide a 2 away from all these three terms. Left over from here would be x squared. Left over from here would be 2x. And left over from here would be negative 15. But again, remember, this is where I could also have another green comment of, remember, always check the bubble factor to see if it can unfoil now, which it can, by the way. So there's going to be a problem like this on the test, where you factor out a GCF and then you unfoil through basic unfoil. What two numbers multiply make negative 15, but also add positive 2? Pause the video if you want to think of it for yourself. Last chance. Negative 15. Well, to make a negative 15, I know at least, because I'm a genius, get out of there, that one number has to be positive and one number has to be negative. It's the only way. It's the only way. Positive 5 and negative 3. Remember, don't forget to bring that factor of 2 down here for the final answer, because you have to. Number 8, is there a GCF? Heck no. Can it unfoil? Well, yeah. So, fix that. Unfoil, yeah, by what method? The first term is just x squared, so it will be a basic unfoil problem. What two numbers multiply to make negative 42, but they also add up to negative what? What number's here? What number is here? Negative 1. So what two numbers multiply to make negative 42, but they also add up to negative 1? Well, again, pause the video if you want quick, but as I'm a genius, I know it's got to be one of them negative, one of them positive. And here we go. Negative 7 and positive 6. Yep. That's it. Number 9, is there a GCF? Could you divide a common factor away from both 12a squared b and 4ab, or technically negative 4ab? Yeah. So we're going to factor out, what is the GCF? Okay, so remember, you kind of can separate it by what's the GCF of 12 and 4? 4. But then what's the GCF of a squared and a to the first power? Technically this is a to the first power, and that's of course a squared. What's the GCF of those two? A to the first. Remember, you go with like the smaller power. And then what's the GCF of b and b, or I should say b to the first power and b to the first power? It's a tie. B to the first power. So that's the GCF that we're dividing out. Okay. And when you divide 4ab away from this term, what's left over? 3, and then there's a factor of a left. We divided one factor of a out, but there is a factor of a left. Again, remember, it's like 4ab times what would make the 12a squared b? Well, this, 3a. And since we divided the b out, there's no b left to be here. So, and then when we divide 4ab away from this term, what's left over? Remember, we're dividing it out. Just one. Just one. Number 10. Is there a greatest common factor? Why does this keep... I thought I fixed all of those. Is there a greatest common factor? Nope. Does this unfoil? Yep. But seeing as how we got a 3x squared, Phoenix method time. So remember, don't need to drag our feet through the steps, so slowly this time. So get rid of the Phoenix. 3 times 8 is 24. Basic unfoil. How do we get positive 24, but also negative 14? Well, because I'm a genius, I can say for starters that it's going to be a couple negatives. Negative something times negative something else to make a positive 24, but they add up to negative 14. Negative 12 and negative 2. And then remember, you're not done. It's time to bring the Phoenix back to life in all its fiery glory. Yeah. And then what? You have a couple fractions. So you reduce any fraction that you can. And look, 12 over 3, you can say that's 4 over 1, but it's really just 4. 12 divided by 3 divided cleanly. It did more than reduce. It divided clean. So that'll just become a 4. And then 2 over 3 doesn't reduce at all. So the 3 bumps up, and you have 3x minus 2. And that is your answer. Phoenix method. Number 11, is there a GCF? Nope. So if this unfoils, considering it's only got 2 terms, for this to unfoil, the heck with it. For this to unfoil, it needs to be the difference of 2 perfect squares. Or, but it will, and this is where, stupid thing. As long as it's the difference of 2 perfect squares, which it is. 4x squared is a perfect square, and 9 is a perfect square. The perfect square root of 4x squared is 2x, because 2 times 2 is 4, and x times x is x squared. And then to finish the bubbles, along with the plus and the minus, square root of 9 is 3. And again, I guess I wouldn't be completely thorough if I didn't mention this. Hey, you could have also thought of this as, I want there is a middle term. It's 0x. But then you'd have to go through the Phoenix method, all the steps of the Phoenix method, which will work, but just recognizing this as the difference of two perfect squares saves you all that trouble. But you could think of there being a middle term of 0x and then do the Phoenix method, whatever. And then number 12, is there a GCF? Do all 3 terms have anything in common? No. So as far as unfoil goes, it's just going to be basic unfoil, right? Basic unfoil, where you think of the 2 numbers that multiply to make positive 80, but they also add up to positive 18. And again, let's have this come full circle with me reminding you just one more time that, hey, some of you are going to figure out the 2 numbers like that. But some of you are going to just take a little bit longer, maybe even needing your calculator to help you come up with all the possibilities, like 1 and 80, 2 and 40, 3 and nothing. So far it's 1 and 80, 2 and 40, 4 and 20, 5 and 16, 6 and nothing, not 6 and anything, so 5 and 16, and then 8 and 10. And it turns out the last one I said was the correct one, because these two numbers also add up to positive 18. So there it is. It's those 12 questions and those exact kind that you need to be ready for on the test. So thank you for following along. Have a good evening or day or morning or whatever.